lost in the supermarket. I can no longer shop happily. I came in here for a special offer.
Alright, so I want to do one more example. We'll do this really quickly. Or, not really quickly, but very thoroughly. So let's say we're given sine squared x times cosine squared x dx. So now we're confronted with a problem that involves both sine and cosine. And they're both raised to a power higher than 1. So as we know, this sine squared x could be 1 minus cosine squared x. So we can plug that in. So we could actually get 1 minus cosine squared x times the cosine squared x out here, which when you distribute, then we get cosine squared x minus cosine to the 4th x, and then all of that times dx, right? Okay, so then using the trig identity for cosine squared x, then we can simplify this into 1/2 1 plus cosine 2x, the double angle formula again, and then we'll separate the second part because this is kind of like a thing of its own in a way. So then we have cosine to the 4th x dx. So now for this part, this is where the reduction formula comes into play, which again is on page 419 if you need to reference it. And so basically we're going to have, let's see. All right, so we'll have the 1/2 can come to the outside of the first. Let's see, wait, hold on. Of 1 plus, oh, there should be a dx here. Sorry about that. Cosine 2x and then dx. And then, so the reduction formula actually looks like, once you apply it, then we'll get 1/4 and then cosine 3x times sine x, and then plus a 3/4. I'm going to try to make this still legible as I squish it in. Cosine squared x dx, and then close bracket. Okay, so then for here, we can actually, here referring to the first part, we're going to apply the u substitution. So our u could be 2x, right? And our du is 2 dx, all right? So then going on to the next slide, since I ran out of room. So if u is 2x and du is 2 dx, then we can replace that with 1/2 of 1 minus, or plus, that's a plus, cosine u, right? And then the du actually turns into a 1/2 du. That's what dx is. All right, hold on one moment. Let me go back a second. All right, so let me write out what we had before so we don't get confused. So we have the 1/2 was on the outside, right? Then we have 1 plus cosine 2x dx. All right, so actually, and then the rest. So I'm just working with the first part here. So this is first part before the minus sign. And so we're making our u be 2x and our du is then 2 dx. So what I'd like to do here is actually separate this before we apply the u sub, because it can get kind of confusing with the 1 out in front here. So this, if we break it up, it's just the 1 dx, and then we could break it into a separate integral like that, right? So now we have our cosine 2x dx. So this, again, this is all what I'm writing here. This is the first part of the integral. So this turns out to be 1/2 x for this. And then when we apply u sub here, then this is cosine u, and then the dx becomes a du over 2. Okay, so du over 2. All right, so now we have 1/2 x out in front, and then this 1/2 here can come out in front as well. So we have a 1/4, and then cosine u du, and then we just integrate like normal. So I'll go up to the top here from our room. So then we have 1/2 x, and then this will be a plus 1/4 sine of u plus c, right? And it's positive because the first derivative of sine is a positive cosine, okay? All right, and then the last step here for the first part is to plug in our 2x for the u. So the first part's going to look like this. 1/4 sine of 2x plus c. Okay, so keep this in mind. Jot that down in your notes if you haven't already. And now we're going to move on to the second part. Okay, so the second part looks like, so part 2 is this thing, the cosine to the 4th x dx. Okay, and this is where we're going to use the reduction formula, like I said before. So we actually got 1/4. So I believe I wrote this on a previous slide, 2 slides ago. So this is what it looks like once you apply the reduction formula thing, 2x and then dx. Okay, so I wrote that previously, and now once you apply the reduction formula again for this one, then we will get, this is going to be kind of expansive, so just bear with me here. Okay, so then we'll have our 3/4, right? And again, the reduction formula is on page 419 if you need to see it. Like I said, I don't want to write it all down here, and then that'll take up even more space and even more time. So we actually get 1/2 cosine x sine x plus a 1/2 x. Okay? And then plus c, of course, because it's still an indefinite integral. So this is what we get for the second part. This is like that, okay? So if we recall, so again, write this down in your notes. This is part 2. So our final answer is going to be part 1 minus part 2, right? So altogether, this is going to be, let's see if I can fit this in one line. 1/2 x, and then plus the 1/4 sine of 2x plus c, technically. And then we're going to minus part 2, or subtract part 2, which is 1/4 cosine the 3rd x times sine x, and then a plus 3/4. Ooh, that was sloppy. Okay, I don't know if I'm going to make it here. 1/2 cosine x sine x. Sorry this is so long, but that's kind of the nature of these problems, so kind of going to have to deal with it. I'm sorry. And then a c. That's a plus c at the end. Sorry about that. That is a c. Okay, so these two c's, they can just combine into one because they're just some constant, right? So we're actually going to have, well, all right, I'll write the final ultimate answer. So we're going to have this, and sine of 2x, and then just distribute the negative. So negative 1/4 cosine to the 3rd x sine x minus a 3/8, right? Minus 3/8 cosine x sine x. And then, let's see, we distribute the negative again, and then 3/8x and a plus c. So this, ladies and gentlemen, is our final answer. Finally. Okay, so even though this problem was kind of sort of long-winded, in a conceptual sense, these whole like sine and cosine problems raised to different powers, it's basically just taking forms of like these trig functions and applying the identities and manipulating it so that you get your answer. So yeah, it sounds easy, but the execution is a bit, like I said before, long-winded.
Come along and shop happily.